Hi guys, today we're going to be looking at a question on chemical equilibrium. Dinitrogen tetroxide, N2O4, decomposes to nitrogen dioxide in a sealed syringe of volume 2 decimeters cubed. The mixture reaches equilibrium at 325 degrees Celsius, according to the following balanced equation. When the equilibrium is reached, it is observed that the color of the gas in the syringe is brown. Question 6.1. State Le Chatelier's principle. So, Le Chatelier's principle says that when the equilibrium in a closed system is disturbed, the system will reinstate a new equilibrium by favoring the reaction that will oppose the disturbance. Question 6.2. The syringe is now dipped into a beaker of ice water. After a while, the brown color disappears. Is the forward reaction exothermic or endothermic? Explain the answer using Le Chatelier's principle. So, the forward reaction is therefore endothermic, as a decrease in temperature favors an exothermic reaction due to heat being produced in an exothermic reaction. And since the decrease in temperature favors the reverse reaction, this shows that the forward reaction is endothermic. Question 6.3. The volume of the syringe is now decreased while the temperature is kept constant. How will each of the following be affected? Choose from increases, decreases, or remains the same. Question 6.3.1. The number of moles of N2O4 gas. So, since the volume has now decreased, and we assume that the concentration remains the same, this means that the number of moles will therefore increase. Question 6.3.2. The value of the equilibrium constant. Since chemical equilibrium is only affected by temperature and not by the volume, the value of the equilibrium constant will remain the same. Question 6.3.3. The rate of the forward and reverse reactions. Since there is now an increased amount of moles and an increased concentration, this will cause the rate of the forward and reverse reactions to increase. I'm going to do the next question on a new page so there's more space to work out. Question 6.4. Initially, X moles of N2O4 gas were placed in the syringe of volume 2 decimeters cubed. When equilibrium was reached, it was found that 20% of the N2O4 had decomposed. If the equilibrium constant for the reaction is 0.16 at 325 degrees Celsius, calculate the value of X. To do this, we can draw a table having N2O4 and having NO2. We can then say our initial moles. At the beginning, we don't know how many moles of N2O4 we have. And since it is the start of the reaction, we have 0 moles of NO2. We then want to calculate the change in moles. We know that the change is 20% of X, so we can say 0.2X. And since the ratio of N2O4 to NO2 is 1 to 2, we therefore have a 40% increase of X. We then can calculate the equilibrium moles. I'm just going to say EQ for equilibrium. And since we have lost 20% of X, we have 0.8% left. And here we have 0.4X. Now we want to calculate the equilibrium concentration. And since our volume is 2 decimeters cubed, we can say this value divided by 2, and we get 0.4X. And here we get 0.4X over 2 and get 0.2X. We then have a known Kc value, so we can say Kc is equal to the concentration of NO2 squared, as it is a 2 in the formula, over the concentration of N2O4. And we can plug in our values, Kc being 0.16, the concentration of NO2 at equilibrium being 0.2x, and this is squared, all over 0.4x. And when we solve for x by rearranging, we get x to be equal to 1.6 moles. And that's the initial amount of moles we have of N2O4. That's all for this video. Thank you.